Right, hi class. Today we're going to look at oxidation reduction reactions. And so they're commonly called redox reactions. So we tend to say metals oxidize. What does that mean? Well, another name for oxidation when we think of metals is rusting. So metals rusting. Really what's happening here, metals are combining with oxygen. And as a result, when something becomes oxidized, they're going to lose electrons. So there's a saying when we're talking redox reactions. It's called oil rigs. So if you want to take out your notes, yellow packet here, we're going to turn to page 12, the back of the back page. So page 12, take that out, and we're going to work through this page here together. So one thing I recommend you do right now is to write down the saying, oil rig. What does that mean? Oil, O-I-L, oxidation is losing electrons. So the process of oxidation is something is getting oxidized. It is losing electrons, and that is going to make it more positive. And reduction, R-I-G, reduction is gaining electrons. So if an element becomes reduced, it is stealing, it's gaining extra electrons. It's going to become more negative. All right, so oxidation is losing electrons. Reduction is gaining electrons. There's another saying out there. Leo goes grr. So Leo, the lion, goes grr. Leo, L, loss of electrons is called oxidation, and gain of electrons is reduction. So same thing as oil rig. We got Leo goes grr. So use either saying to figure out what's going on here. It's an easy way to remember. So remember the charges. So you have to be able to figure out what's the charge of each material in the beginning and the end. So remember, group 1 metals plus 1, group 2 metals plus 2, group 3 metal or 13 elements, group 13 is plus 3, and then group 15 minus 3, group 16 oxygen's family minus 2, and group 17 halogens minus 1 charges. All right, so page 12 of your notes, let's do the first practice problem. It says iron metal, iron solid, reacts with aqueous silver nitrate to produce aqueous iron nitrate plus silver metal. So the question is this a redox reaction? Is this oxidation and reduction? Are things gaining and losing electrons? Well, we got to look at the charges. So label the charge of everything. We have iron by itself. So anytime a metal or an element is by itself, everything's neutral, all right? So atoms by themselves are neutral. So I'm going to put a 0. This iron atom would be a neutral atom of iron. It would have the same number of protons and electrons. So this iron would have 26 protons and 26 electrons, and that means it's neutral. Silver is part of an ionic compound. So that means it's going to have a charge. It's going to be an ion here. So silver is always positive 1. And then the nitrate has a negative 1 charge. That's one of our polyatomic ions on the green sheet. Iron now on the product side, it's no longer neutral, right? It's part of an ionic compound. It's iron nitrate. So I got to figure out, all right, the nitrate has a negative 1 charge. That didn't change. But the iron, because there's 2 nitrates, the iron has to be positive 2. So this is iron 2 nitrate. And then look, the silver ends up by itself. Anytime you have an element by itself, it's going to be neutral. So silver would have, it's element 47. So it would have 47 protons and now 47 electrons. So 0 charge. So what I like to do, I like to draw arrows to connect things. So here's iron on the left side. I'm going to draw an arrow to connect it to the iron on the right side. And look, the charge of the iron changed. It went from being neutral to now being plus 2. And what else changed? The silver started out being plus 1. And now the silver ended up being 0, neutral. So we do have a gaining and losing of electrons. So is this a redox reaction? Yeah, we have things being oxidized, we have things being reduced. So which element is being reduced? So remember, rig, R-I-G, reduction is gaining electrons. And so iron lost 2 electrons, right? It went from being neutral to losing 2 electrons, now being plus 2. But look, silver started out with a plus 1 charge, and now it's neutral. So that means silver had to gain an electron. So silver, Ag, is the element in this reaction that gets reduced. It gains an electron. What is oxidized? What loses electrons? Well, iron started out with 26 protons, 26 electrons, but it ends up with a +2 charge, so it ends up with only 24 electrons. So the iron had 2 electrons taken from it by the nitrate. So iron lost electrons, it's oxidized. Silver gained electron, it is reduced. So this will be a redox reaction. So single replacement reactions are pretty much always going to be oxidation reduction reactions, because the more reactive metal is going to replace the less reactive metal, and there's a transfer of electrons in that process. So here we got sodium and chlorine combining to make table salt. So start out by labeling the charges. We got element by itself, sodium by itself, so it's neutral. We got chlorine by itself, so it's neutral. Same number of protons and electrons, but they link up to form an ionic compound. So ionic compounds, sodium would have a +1 charge, chlorine would have a -1 charge. Draw arrows to connect them. So sodium goes from being neutral to +1. Look at chlorine. Chlorine goes from being neutral to -1. So yeah, they change charges. There's a transfer of electrons. So this is a redox reaction. Which element's reduced? Remember, oil rig, RIG. Reduction is gaining electrons. So chlorine went from being neutral to now being -1. So chlorine is reduced. And which element's oxidized? Well, sodium lost an electron, went from being neutral to +1. So sodium, Na, is the element that is reduced. So typically metals get reduced. Whenever metals and nonmetals react, the nonmetal steals electrons from the metal. Let's look at number 3. Magnesium metal reacts with hydrochloric acid to make magnesium chloride and hydrogen gas. So let's look here. Magnesium by itself starts out being neutral. Hydrogen in the hydrochloric acid, we treat it like a group 1 metal here. When it's an acid, we give it a +1 charge. Chlorine, group 17, -1. In the end, we got an ionic compound. The magnesium would have a +2 charge. Let me try to write that again. And the chlorine, chloride is -1. And then hydrogen ends up by itself. So things that end up by itself would be neutral, right? So atoms, elements of atoms, when they're in a pure form, are neutral. So connect the things that are changing with an arrow that helps you see what's going on. And so I have, yes, this is a redox reaction. Things are changing charges. There's a transfer of electrons. Magnesium goes from being neutral to +2, so that means it lost 2 electrons. So magnesium would be oxidized, right? Oxidation is losing electrons. And which element's reduced? It would be hydrogen. Hydrogen starts out with only a +1 charge, a proton, and no electrons, but it ends up neutral. So hydrogen gained an electron through this whole process. So that's reaction 3. And now I know your notes only have 3 reactions. I want to show you this example here. Double replacement reactions. Is this a redox reaction? So it's a double replacement reaction, a redox. Double replacement reactions are typically not. And here's why. Look, everything keeps the same charge. So sodium starts out +1, chloride starts out -1. Nitrate's -1, that means the lead is +2. All right. On the other side of the equation, I ran out of room. I had to write down below here. So let me just draw a line here. So this is the left side, this is the right side. So look at the charges of the things on the right side. Sodium's still +1, nitrate's still -1. Chloride is -1, and lead would have to still be +2. So if I compare the charges, like look, sodium still has the same charge, chloride still has the same charge, lead still has the same charge, nitrate still has the same charge. So this is not a redox reaction. All right, things have to switch charges. All right, so there you go. So you want to turn now to page, I believe it's page 16 in your white packet. Let me double check and grab my packet before I let you go. Yeah, right now, try to use this information, work on page 16 in your white packet, and have a great day, everybody. I'll see you next week.